Gentlemen, welcome back to the shop. There are those of us who can learn from other people's mistakes. I have to learn from all my own mistakes the hard way. 2 times. Those in the know will recognize this as a big mistake. On the frozen shithole of Hoth, this is a very common problem. Lead acid batteries freezing. Luckily, we can recover it using Epsom salts. There doesn't seem to be much hope for this bateria, but we'll answer the age-old question as to whether Epsom salts are just the cock for dolly for recovering lead acid batteries. And I will prove to you that indeed they are just that. All that's needed now is a vigorous shake and a little bit of time. Some time has elapsed and we'll check on our battery. Voila! Epsom salts will repair a sulfated battery in a small minority of cases. It doesn't repair all batteries. It needs a very specific kind of fault in order for that to repair. And that's an old age fault essentially in the battery. These are consumable goods. Lead acid batteries, very high, not so high in energy density, but very high in power density. So when you're cranking an engine, they're very high, but they beat everything else in cost and something else. Recyclability, as well as, I forget, ease of charging and discharging, which is a function of its robust construction. The thing is lead plates. Heavy, strong, stout, skookum, one might say. Been around for hundreds of years, probably 150 years, this technology hasn't really changed all that much. One, cost, obviously. Now, lithium-ion batteries coming down in cost, pretty much comparable for energy density, and they're a little bit better for power density. Now, you want power density for a cranking battery because you got to draw 1,000 amps to get the starter motor engaged to turn over your internal combustion engine. So, what we are going to do here is go over batteries, mainly with an eye to dispelling myths, as well as telling you how you can take a crappy battery, sort of kind of half-ass get you out of a pickle with some Epsom salts, and also address what I haven't seen addressed is why sticking Epsom salts in a battery, a lead acid battery, actually can recover it in some instances. Surreptitiously, over the holidays, I made a $500 lapse in judgment. What can I say? I'm as idiotic as the next guy. I'm human. Okay, you get an old battery. It's a lead plate and a lead plate. Then they change one lead plate to lead dioxide, and then pure lead plate. They put that in a bath, separate them. They put that in a bath of sulfuric acid, dilute sulfuric acid, maybe 10% sulfuric acid in dihydrogen monoxide, that hoary old toxic bit of waste, also known as water. Here we have one of the plates, which appears to be the negative, or the cathode. No, the anode. No. I get this wrong every time. Don't panic. Positive anode, negative in cathode. So, if this is positive, then that is the anode. Positive anode. Yeah, that's right. Okay, so lead plates. Oh, there we go. Here's lead plate. And here is a lead oxide plate. You see the difference in the color. Now, this is amorphous. We'll get into that. I'm getting ahead of myself here. I want to give you the broad strokes before I get into the itty-bitty titty committee. So, when the battery is charged, you have pure lead on one side, pure. On the other side, you have lead oxide, a lead dioxide, 2 oxygens on there. And in betwixt the between is some acid. Can I explain something? Draw yourself a picture. Download the latest version of AVECAD. Oh, some guy's always thinking of a little D. That's the thing. You could download the DaveCAD. Some guys are willing to pay for a little D. I hear you can download it for free off the grinder. So what we got is PB Plumbum 02, and then we have straight up Plumbum And then we have H2SO4 and a Q, aqueous. So what happens is when we have a light bulb connected here, electrons can flow from the, well, which would be the cation. I don't fucking care. You look it up if you want. Goes from the negative. Oh, I think that's reversed. But then never second guess yourself. So we got electrons going through this little light bulb and then through the solution. What ends up happening is both of these turn into sulfide, lead sulfide, sulfate. The O2 off gases, right? On the, that's the wrong one. No, that's the right one because the H2 is the, yeah, that's right. So O2 off gases off the positive, H2 gas off gases off the negative, and you get Pb sulfate on both plates. Okay, Epsom salts are magnesium sulfite. So when this battery is discharged, the amorphous blobs, this is not solid, right? This is like a paste. It's a paste in order to increase the surface area. This is a chemical reaction. You want to increase the reaction, you up the temperature, and you increase the surface area. So in this case, we're not worried about temperature, but you increase the surface area. Now this forms a crystal, this PbSO4. This forms a crystal. Crystals are not particularly conductive. They are highly resistive. So the internal resistance of the battery goes up and up and up as this balance changes over from the two metals to the two salts. Now, if there is a layer of crystals, what is allowed to crystallize, now if you drain a battery and let it sit drained for a long time, more of those crystals are going to form faster. So it can either be a really old battery or it can be a dead battery what sat around for a long time. These sulfites, they crystallize. So what do you do to get those crystals off of the plates? Well, you put some of like into solution. Now this magnesium is magnesium sulfate. Jesus Christ. I think I'm having a stroke here. So what happens if you have this in solution is you end up putting a round hole in a square peg. These two kind of crystals cross hatch and go in and out of solution. This is a totally different shape. If I recall my kindergarten material science, now the problem was I only audited it and it was the electrical engineering version, not the real engineering version. So talked more about silicon dopants and how fast electrons actually move in conductor. You'd be surprised how slow an electron actually moves in a copper conductor. It's like a meter a minute. It's super slow. Anyway, so I had to learn this didactically, so bear with me here if I need some mnemonic aids. I've done this before. Magnesium sulfite has a monoclinic crystal pattern. Okay, so that means that if you look at the crystal from the top here, A, B, and C. A and B are the same length. C is a different length. And one of these angles, angle theta, or I think they call it, no, they probably call it the angle beta, is not square, so it's kiltered off. This guy, and you can see these crystals. They're crystals, right? This guy has a ortho. It has a different fucking thing where A and B are equal, C is different, and all of these angulations are perfectly square. So, when you inject one of these crystals into this, it causes it to slough off. So what you get in the bottom of the battery is you get sloughed off sulfates. The difference, okay? Here's the difference between a cranking battery and a deep cycle battery. There's three main things. Deep cycle battery, the plates are further apart. They're more skookum. There's more material there. And the silt trap or the crud trap underneath is deeper. So for a deep cycle battery of comparable size, you get less chooch for your chotch because they're giving you more room to slough off these crystals from cycling or being deeply cycled. So that is the difference between a cranking battery and a deep cycle battery, is you get less chooch for your chotch because they're giving you more room for all this detritus to fall off. The long, well-veined, and slightly curved to the left of it is when you add some Epsom salts to the battery, what you are doing is allowing these sulfites to slough off. You're helping these along. It wouldn't hurt to agitate it as well as heat it. Of course, after you put this in, the recipe is always charge it up. What does charging it do? It also helps to heat it up. And it also helps to agitate it because some of the water in there is going to be turned into hydrogen gas and oxygen. Aeration, bubbly, it mixes everything up. All that sulfite slips off to the bottom. Now here's the thing. The Epsom salts only work in that one case where there is crystallized sulfites on the plates. It doesn't work in any other battery failure mode. For instance, if it's a really old battery, like a cranking battery and not a deep cycle, that trap for the silt is not going to be very big. What can happen is you can fill that up with a resistive material and you have what they call a soft short between the plates. And then what happens is after you charge it, it'll be fine, but it will very quickly die again because it's short-circuited internally. And that's what's happening with Forky McForkface, the 60-year-old Forkum lift at the other shop. Is internally that battery is fuckered. Now I just keep it topped up and hope for the best because quite frankly buying a battery is worth way more than that forklift is worth. So they're just kind of creeping a little on, and that's the thing. When you repair it with Epsom salts, you're not bringing it up to full capacity. You're just buying a little time because ultimately a lot of that material has sloughed off into the bottom, and now you don't have as much capacity because you don't have as much surface area. Now, are you still with me? Chances are you're a Y guy. I'm a Y guy myself. There's always a video on how to do something. Never tells you why it works or why it doesn't work. So, in this case, I'm also going to dispel the myth that you cannot store batteries on a concrete floor. They always release these platitudes, these old wives' tales. Now, I'm a happily married man, but I'm not objective to having an old wife tale once in a while. The reason it used to die, because batteries, they've been around for, they predate plastics. So the casements could have been rubber. And if you have rubber, then rubber seeps fluid. It seeps the acid through. The acid is an electrolyte. If it's sitting on the ground, it can pool into all the pores of the concrete, completes a circuit, and then your battery dies on concrete. In this case, in this day and age, and for the past 80 years, they've been in plastic. That doesn't happen anymore. So forget that wives' tale altogether. Unless you have a battery that is encased in rubber, it ain't gonna go dead on concrete. Now, a couple more failure modes. Let me weave you a tale of woe. Well, I left this in the trailer over the holidays. I figured first off, the battery froze. How did the battery freeze? Well, it went dead. So a fully charged battery will not freeze in less than 70 dungarees science. We're not using that Frankensteinian. How many centigrade to the inch? I have no idea. Good guess, 9. But as the battery dies, the eutectic, well, no, the colligative properties change depending on the concentration of acid in here. And as the battery dies, remember that sulfite, the hydrogen, gets evolved as a gas, and the sulfate, this is the acid, the sulfate gets stuck as a salt to the lead. So what happens to this aqueous solution? It gets lower and lower in concentration until it's basically water. A totally dead battery will freeze at 0 degrees. Fortunately for us, though, you can never get to a totally dead battery because the internal resistance, once these crystals build up, is so high that it's impossible to fully, completely, stoichiometrically complete the chemical reaction. So you're always going to have some acid in there which is preventing it from freezing at 0. But if there's very little acid in there, it will freeze at, say, -10, which is the case with these deep cycle 6-volt batteries, what were in the trailer. I have a solar panel trickle charging these all the time. I thought to myself, it'll be fine for a little bit, I'll get to it, yada, yada, yada. Life gets in the way. It snows. Huh? What does snow do? It covers up the solar panels. The batteries get drawn down. We get a little bit of a cold snapper, titty bit nipply. Bingo bango, $500 in the difference. So how do you fix this one? Ain't nothing for it. Can't fix it. But what we can do is learn from it. Even more so than I'm an idiot and I ought to be supervised by at least an adult or 3. So we have the positive plate here, and you can see very quickly another easy fault for these rattling and banging around in the back of a trailer or a vehicle for that matter is they can very easily break off. You see that? I just broke that. So wiggling this around, the lead, and this is not pure lead either. Pure lead is like this. It's very ductile. Pure lead is no good for anything. It's not good for anything other than radiation shielding. What they need to do for wheel weights and for bullets is they need to add antimony. And antimony stiffens up the grain structure so that it's not as ductile. It's the same as brass and bronze. Brass, it's copper, say 60% copper and 40%, I'm not sure. Yeah, with something like 40% zinc. It's very malleable because if you look at the grain structure, it's all these grains with tons of boundaries. Okay, you take copper and you add tin to it. Now you get bronze, and bronze that makes swords out of. It's not malleable at all. What is the difference? If you look at the grain structure of bronze, yes, you have these kind of amorphous looking crystals of copper, but the tin is not as soluble in the copper as zinc is. So what ends up happening is you have these dendrites, which are little stickly looking things that form as the bronze cools. That locks everything together. That means that you can make a bell out of bronze, bing, but you make that same shaped bell out of brass, boom. So they add antimony to these grids to stiffen them up. So this is not pure lead. This is the kind of lead what would be good for making bullets because it's a little bit harder. You put a fully lead bullet in a modern rifle and it turns to shmoo. Makes a hell of a mess. If you're casting your own bullets, you already know that. But just, you never know. When you're getting down on the mountain, that hoary old, that Cor Blund saying, you ever seen a man whose kids ain't ate for 17 days and counting? And then there's a little piece of fabric separating to make sure there's no physical contact between the anode and the cathode, that the anode is the negative and the cathode is the anode is the positive. Jesus. Reiterating what faults we can have in a bateria is the sulfation. can be mitigated slightly by Epsom salts. Listen, it's on the way out. Most of faults in the battery are resolved by chucking it right in the bucket. But if you want a kind of craptacular standby battery, which you don't need to rely on, you can get some little bit of capacity out of a totally pooched battery by adding some Epsom salts. Other faults are not going to help you at all. For instance, if this silt trap is right full of shmoo and you have a soft short internal in the battery, Epsom salts ain't going to fix it. If you have a physical connection, what's broken, Epsom salts, not going to fix it. If you have a short between the cells because one of these wore through or moved away from where it was supposed to be, ain't going to help you. One fault that is super scary, and this happens very frequently and people don't pay any fucking attention to it, exploding batteries. Remember, as these are charging and discharging, hydrogen gas builds up on the negative terminal. Hydrogen gas is explosive. Be fucking careful. So, when you boost a vehicle, what do? The final connection should be to the negative. And it should not be to the negative of the battery. It should be to the chassis of the chassis ground. Because when you put it on the chassis ground, it's going to spark. If you put it, this is equivalent to the chassis ground. That's the positive. But the negative over here, this is connected to the chassis ground in the truck or the bulldozer or whatever. But if you put a clamp on here and you make the final connection at the negative, there's going to be a spark there. What do you need for an explosion? You need an oxidizer. Well, you got oxygen all over here, off-gassing off the other one. You need a spark. Well, you got that now. And you need something to combust. Hydrogen gas is quite combustible. Inflammable as well, I'm told. Pretty much exhausted everything to do with lead acid batteries, at least on the cursory kind of, it is a YouTube video after all. It can't be. We got to satisfy the pedants or people too. Thanks for watching. Keep your dick in a vice.